This video is on coordinate geometry. We are going to prove mathematically what type of triangles we have. We are not going to look at the picture and assume or guess, but we are actually going to use our properties and coordinate geometry to prove that it is the triangle we believe it is. So the first examples say which type of triangle is graphed. We need to classify by side and by angle. So there are two different ways we have to name our triangle. Then we need to find the perimeter of each. So perimeter means to add up all the side lengths. So no matter what, we have to find all the distances. We're going to round to the nearest tenth if necessary. So to find the distances and slope, those are the two things that we're going to find every time. So first side, we're just going to mark them to know which sides we're dealing with. So I'm going to use a highlighter to show the different sides. I am going to say I'm going to use yellow. No, I'm going to use, not yellow, I'm going to use green on this side down here. I'm going to use purplish pink on this side right here. I'm going to use blue on this top side right here because I don't have any letters on here, so I'm going to use colors to help me with knowing which side goes with which. I could label them, but I'm just going to use colors for this. So for the blue side, I'm going to use blue. I'm going to find the distance of this blue side. To do that, I'm going to use Pythagorean Theorem. I'm going to figure out the change in the vertical and the change in the horizontal and use that as my A and my B. I'm going to go from this point, counting up, I'm making a right triangle, counting over to the other coordinate. So my distance is going to be the square root of A squared plus B squared. So remember, distance will equal to the square root of A squared plus B squared, because that's the distance or the change in x's and the change in y's. So I'm going to have 1, 2, 3, 4, 5. This is a distance of 5 spaces. Then I have a distance of 1, 2, 3, 4, 5, because I'm watching my scale as well. This is also a distance of 5 spaces. So I have the square root of 5 squared plus 5 squared. So I have the distance of the square root of 25 plus 25, which is equal to D is equal to the square root of 50. So I'm going to keep it like this for now because I don't want to simplify anything yet. I can when I get my perimeter, but I'm going to keep everything as it is right now so I don't have decimals. I also need to find my slope. And remember, slope is change in y over change in x. So I've already counted actually, so the distance formula will help me to find my slope. So my change in y is going from one point, that's a positive 5, over my change in x was a positive 5. So my slope is equal to a positive 1. Now I want to do another one of the lines. So I'll do the purple line. Let's go with the purple line. So my distance for my purple line is equal to, I'm going to find the distance for my vertical and my horizontal. So I have 1, 2 for my horizontal, and I have 1, 2, 3, 4 for my vertical. So I have the square root of 2 squared plus 4 squared. So I have the distance is equal to the square root of 2 squared is 4 plus 4 squared is 16. So I have the distance is equal to the square root of 20. So right now I notice that these values are not the same, so that's fine. Then I want to find the slope. So slope is again change in y over change in x. So my change in y is, I got to be careful since I went from this coordinate to this coordinate. My change in y is a down 4, so I went negative 4. Divided by I went towards the right, so I went positive 2. We have to be very careful about watching our signs. That is a negative slope. So our slope is negative 2 for the purple. Then the last one is the green one. So again, I want to find the distance, so I'm going to do my from one point to the next. So I have a distance of 1 here, and a distance of 1, 2, 3, 4, 5, 6, 7 on the horizontal. So distance is equal to the square root of 7 squared plus 1 squared. So I have distance is equal to 7 squared is 49. 1 squared is 1. So I have distance is equal to the square root of 50. Now, this one is in fact equal to the distance of the blue. So that's helpful. We also need to find the slope. So change in y. So from this point right here at 4, negative 2 to negative 3, negative 3, I went a change in y of down 1. So I went negative 1. And then I went towards the left, so I went negative 7. So our slope is a negative 1 divided by negative 7, which is a positive 1 over 7. So if we go back to our properties of triangles, we have two sides that have the same distance. That means it is isosceles. So to name it by side, this is isosceles. If we have all of the angles in here are smaller than 90 degrees, and we have no right angle, so we have no opposite reciprocal slopes, that means that we do not have any right angles, and all of them appear to be smaller than 90 degrees, then this would be, to name it by angle, would be acute. This is an isosceles and an acute triangle. So we could call it acute isosceles. To find the perimeter, what we would do is take, in our calculator, we will take the square root of 50, make sure we get out of the square root of 50, add the square root of 20, get out of that, plus the square root of 50 again, get out of that, and press equal. We would get the perimeter is approximately 18 and 6/10 units. So now we have our entire name. We have it's isosceles and it's acute, and we have the perimeter to be approximately 18 and 6/10 units. We're going to do the same thing on question 2. We are going to get our different lengths here. So I have a green length here. I have a kind of pinkish purple length here. And I have a blue length here. It's whatever colors you want to use, as long as you're using, or you can name them however you want to do it. I'm going to do the same thing, finding the distance and finding the slope, because those are the two things we always want to use. So for the blue, the distance, using Pythagorean Theorem, I'm going to count. So I have, using my scale, these are all counting by 1. So 1, 2, 3, 4, 5, 6, 7, 8. And I have, on the vertical, 1, 2. All right, so distance is equal to the square root of 8 squared plus 2 squared. So that is the square root of 64 plus 4. So I have the distance is equal to the square root of 68. We're going to keep it like that for now. We need to find the slope. So change in y from coordinate to coordinate went in the down 2, so that's a negative 2, divided by, we went towards the right, that's a positive, so that's a positive 8, which is equal to a negative 1/4. So that's our slope. Distances and slopes we're going to separate. So now we're going to do the purple one, purplish pink. So I'm going from coordinate coordinate. So I went 1, 2, 3, 4 on the vertical and 1 on the horizontal. So distance is equal to the square root of 4 squared plus 1 squared. So that's equal to the square root of 16 plus 1. So distance is equal to the square root of 17. So then our slope, we went from the change in vertical, change in y is down 4, so that is a negative 4 divided by a, we went to the left, which is a negative 1. So that's equal to negative 4 divided by negative 1 is equal to a positive 4. That is our slope. And if we look, negative 1/4 and positive 4, those are opposite reciprocals of each other. That means that we have perpendicular slopes. That tells us that we're going to have a right angle right there. And the last one is the green line. So we're going to use the Pythagorean Theorem to help us. So we went counting by ones, 1, 2, 3, 4, 5, 6, 7, distance of 7. And then 1, 2, 3, 4, 5, 6, a distance of 6. So distance is equal to the square root of 7 squared plus 6 squared. So that's equal to the square root of 49 plus 36. So distance is equal to the square root of 85. Then our slope, so our change in y from one point to the next. So I went from this point to that point. So I went up 6. So that's a positive 6 in the change in y. And then I went again from this coordinate at 4, negative 3 to the other one. So I went to the left 7. So that is a change in x of negative 7, which is equal to just a negative 6 divided by 7. So looking at what we have here, we have no sides are the same. Not a single side is the same. So that's scaling. Then we look at our slopes. So we have a negative 1/4 and a positive 4. Those are opposite reciprocals of each other. So this is important. This slope and this slope are opposite reciprocals of each other. That means that we have a right angle there. We have a scaling right triangle. Then we want to find the perimeter. So again, perimeter is we take the square root of 68, make sure you get out of the square root, plus the square root of 17, make sure you get out of the square root, plus the square root of 85, get out of the square root and enter. And we get the perimeter to the nearest tenth is approximately 21 6/10 units. So it's a right scaling triangle or scaling right. We have a perimeter of approximately 21 6/10 units using just the distance and just the slope. So on this last one, it says without a graph, what type of triangle is triangle ABC with these vertices? So we're going to do the same thing we just did, but with using just the coordinates. So we would have the 3 different sides. Our sides would be at, so our sides are using 2 letters at a time. We have AB, which is at coordinate 4, negative 1, and 5, 6. Then we'd go from B to C, which is at coordinate 5, 6, and 1, 3. And then we'd go from C to A. So that would be CA, which is at coordinate 1, 3, and 4, negative 1. So our slopes. So again, I'm going to use my purple, blue, and green. So for AB, slopes. Slope is equal to change in y over change in x. So we'd have negative 1 minus 6, negative 1 minus 6, divided by 4 minus 5. That's going to equal to negative 7 divided by negative 1, which is equal to a positive 7. Then we'll do our length of sides. So I can use the distance formula. or I can still find the change in y and the change in x. So from 4 to 5, I'm just going to look at my numbers. From 4 to 5, that is a 1. So my distance would equal to the square root of, from 4 to 5 is changing by 1. That's 1 squared plus. From -1 to 6, that is a change of 7. And that's the same value I'd gotten here. 7 squared. So I get square root of 1 plus 49, which I get as the square root of 50. So on B to C, I'm going to use purple. Our slope, change in y, so 6 minus 3 over the change in x. So that's 5 minus 1. 6 minus 3 is 3. 5 minus 1 is 4, so our slope is 3/4. Let's do the distance. Square root of, from 5 to 1 is 4 spaces away. Not positive, not negative, it's just 4 spaces away. So from 5 to 1 is 4 spaces away. I'm using 4 and then I'm squaring it. Plus, from 6 to 3 is 3 spaces away, so it's going to be 3 squared. That becomes the square root of 16 plus 9, which becomes the square root of 25, which is square rootable, so our distance is actually 5. That is the length of that side. And then we'll do our final side, which I'll do in green. So I have our slope. So y, -1 minus the next y is 3 over my x of 4 minus my x of 1. So I have -1 minus 3 is -4 over 4 minus 1 is 3. Then I have my distance equals the square root of, so from 1 to 4 is 3 steps away. So I have 3 squared plus. From 3 to -1 is, so if I'm going down, that's 3 to 0 is 3, and then to -1 is another 1. From 3 to -1 is 4 steps away. So that'd be 4, and then I square it. So I get the square root of 9 plus 16, which is the square root of 25, which is equal to 5, since I can simplify that. It is a perfect square. So let's go through and look at our slopes, see if there's any connections. We have a 7 3/4 and -4/3. So these two slopes here are, one's positive, one's negative, so they're opposite, and they are reciprocals of each other. That means we're going to have a right angle in here. So we can say that we're going to have a right angle in here. Then if we look at our side lengths, we have the square root of 50, and then we have two number 5s. That means that we have two sides that are congruent. That means that we have isosceles. We have a right isosceles triangle. Then we can still find the perimeter. We can still find the perimeter by taking 5 plus 5 plus the square root of 50. And if we round it to the nearest tenth, this would give us our perimeter of approximately 17 1/10 units. So we have a right isosceles triangle with a perimeter of approximately 17 1/10 units, using just the slopes and the distance formula, or the Pythagorean theorem.